Hello everyone, I'm Sophia Jundis from grade 12 Mendel. Today, let's define mechanical wave, longitudinal wave, transverse wave, periodic wave, and sinusoidal wave. So before we proceed, let me read the objective. Number 1. Identify the distinguishing characteristics of wave and the features of mechanical wave, longitudinal, transverse, periodic, and sinusoidal wave. So, what is waves? Waves are disturbances that carry energy from one place to another. A wave is a disturbance or oscillation that transfers energy through a medium or space without transporting matter. Example is sound waves traveling through air. Let's define mechanical waves. Mechanical waves, sound waves, require a medium, particles to travel through. Sound and water waves are examples of mechanical waves. Example, water waves in the ocean where water acts as the medium. Mechanical waves are generally categorized into two main types, which is the longitudinal and transverse waves. So what is longitudinal waves and mechanical waves? Longitudinal waves, which vibrations occur parallel to the direction the wave travels and have regions of compression and rarefaction moving through the medium. For example is pushing a slinky backwards and forwards produces a longitudinal wave. A sound wave is a longitudinal wave. It is produced when the air surrounding a vibrating object also vibrates. The air particles produce a series of compressions and rarefactions which then travels and enter the receiver's ear. Examples is sound travels through the vibration of air particles. The next one is transverse wave. In transverse wave, the vibrations occur at right angles to the wave's direction, which particles of medium move perpendicular to the direction of the wave's propagation. Only the energy, not the particles, is transferred through the medium. For example, shaking a rope up and down produces a transverse wave. So let us check first what you have learned in the previous lesson. Let's read the problem. During an earthquake, P waves or primary waves travel the fastest. It can travel through any type of material and leaves a trail of compressions and rarefactions through the medium. What types of wave are P waves? A. Transverse wave. B. Longitudinal wave. The answer is P waves or primary waves are mechanical waves because they require a medium, solid, liquid, or gas to propagate. Since they create a series of rarefactions and compressions, the vibration of the particles in the medium is in the same direction as wave propagation. Thus, P wave fall under longitudinal waves. After we identify what is longitudinal and transverse wave, let's proceed to periodic wave. A periodic wave is a type of wave that repeats itself at regular intervals, both in space and time. In other words, the shape of the wave, like peaks and troughs, is consistent and predictable over time. Periodic waves are characterized by a fixed frequency, wavelength, and amplitude. Sinusoidal wave is a type of periodic wave that has the shape of a sine or cosine function. This wave smoothly oscillates, creating a continuous wave-like pattern that rises and falls in a predictable manner. Sinusoidal waves are the most basic form of periodic wave and serve as a building block for more complex waveforms. They are characterized by the key properties such as amplitude, frequency, wavelength, and phase. Parts of wave, which are the crest, rest or equilibrium position, and throw. Crest, otherwise known as the peak, the highest point of a wave. Rest or equilibrium position, the undisturbed position of the particles if they do not vibrate. Throw, the lowest point of a wave. Amplitude, it is the maximum disturbance from the crest of the wave from its rest position. It represents the wave's height. The unit for amplitude is meters. Wavelength, it is a set distance that represents the full cycle of a wave. It can be measured from the crest to crest, from trough to trough, or any consecutive points in the wave cycle. The unit for wavelength is meters m. Frequency, it is a number of waves passing a specific point per second. The unit of frequency is hertz, which is equal to 1 cycle per second. Velocity of a wave, is it slower wave or faster wave? Wave speed or velocity is defined as the distance a wave travels per second. We can also define wave speed as the rate at which energy is transferred through a medium. The unit for wave velocity is meters per second. Here's the sample problem. While at the beach, you observe that the waves hit the shore at a frequency of 0.5 waves per second. You also estimated the distance between the crest of the wave to be 2 meters. Meters, what is the velocity of the wave as they travel toward the shore? So the answer is the wave travels at 1 meters per second toward the shore. If we're finding the velocity, we will use the formula of velocity equals frequency times wavelength. So let's have another learning activity. Bats use sound waves to detect insects. Suppose a bat sends out a 100 km sound wave at a speed of 343 meters per second. What is the wavelength of the sound wave? So here's the answer. The sound wave produced by the bat has a wavelength of 0.00343 meter or 0.343 centimeter. Summary. Wave, it is a disturbance that transfers energy. Parts of a wave. Waves have amplitude, wavelength, frequency, and velocity. Changes in one property can affect the other features. Types of waves. Mechanic waves. In terms of propagation, waves can be grouped as transverse or longitudinal. Another is periodic wave and sinusoidal wave. And velocity of a wave. To calculate the velocity of a wave, multiply the frequency with the wavelength. And that's all for today. I hope you learned something about this video. Again, I'm Sophia from grade 12 Mendel. Thank you for watching.